Okay, so let's quickly review the different numeric data types that we have available to us in Java. This table summarizes what those types are. The first column gives us the name of the numeric data type. Recall that in Java, which is a strongly typed language, when we use a variable, we have to first declare it. So when we declare a variable of a particular type, this is the keyword, the first word that will be part of that declaration. So if we want to create a variable of type byte, the first word is byte as shown here. If we want to create a variable of type long, the first word of that declaration would be long as shown here. Then the second column shows us how much memory that particular data type requires. And they range from 1 byte for a byte all the way up to 8 bytes for either a long or a double. And then the third column shows us what the capabilities of that data type are, the range of values that it can store. And recall that when you are selecting the data type to solve a particular problem, your first criteria needs to be to make sure that it meets the needs of the program. So you first want to go to this third column and make sure that whatever data is thrown at it for that particular problem, that it will be within the range of the data type as specified here. Then your second priority is to use as little memory as possible. So without sacrificing the first priority, in other words, making sure the program doesn't crash, you want to use as little memory as possible to make your program as memory efficient as possible. So we looked at this already. Let's skip ahead to floating point data types. So if you need to store a decimal, then in that table there's only 2 options. The last 2 on that table of 6 options, float or double. Those are the only 2 data types that can store decimal values. That's also called floating point numbers in computer science and in Java. So that lets us store decimals. And remember again that Java is strongly typed. So once we choose the data type, we cannot change it later. Let's look at an example of this in sail.java. Go. And by the way, this sample code is available for free with the textbook. I encourage you all to download it so you can see it for yourself and also just tinker with it and play with it. So here we are declaring 3 variables of type double. And by the way, this is one of your options. You can declare multiple variables within the same line of code as long as they are all of the same type. So we have the keyword double appearing once, and then we have a list of the variable names with commas in between. And you can put as many variable names there as you would like and end them with a semicolon. So that is one statement declaring 3 variables at once. Then down here, we initialize those variables. Note that they all have decimal values. And then we simply display these literal strings. Remember that this plus sign in this context would be concatenation, so that gets concatenated with the values of these particular variables. We can go ahead and compile and run that. Okay, and there's the output. All right, any questions on that example? Pretty straightforward. In Java, something like this, 23.5, is by default considered to be a double. And if we want to store that in a variable of type float, we have to do what's called typecast it. And one way to typecast is to add a letter after the number. In this example, we have 23.5 immediately followed by a capital F. So that tells Java to typecast that value, in other words, force it to become a float, F for float. And so that's another thing that we can do if we decided that we're going to use a float and not a double in order to save some memory. Floating point literals cannot store other special characters. They cannot store commas or dollar signs or anything else. The only thing they can store is digits and decimal points, and they can only store 1 decimal point each. Okay, you can't have more than 1 decimal point. Floating point literals can also be represented in scientific notation. So this is scientific notation that you should be familiar with, 4.7, etc., times 10 to the fourth power. That basically means that we're multiplying the number times 10,000. In other words, we're going to move the decimal point 4 positions to the right. So these two numbers are equivalent. 47,281.97 is equivalent to, notice the two equal signs, that means is equivalent to 4.7, 2.8, excuse me, 4.728197 times 10 to the fourth power. Now Java, as well as many other programming languages, use E notation to represent scientific notation. In other words, the way you would type this number in Java would be like this: 4.7, etc., and then capital E 4. So that stands for exponent, and that's basically shorthand for times 10 raised to that power. So this would be 4.7 times 10 to the fourth power. In other words, these two numbers are equivalent. Okay, questions on that? So here we have numbers represented in a few different notations. The left column is standard decimal notation. Then we have scientific notation. And on the right, we have E notation. So this is how we would have to write things in the computer. This is also how Java would display these numbers by default, unless we tell it to do something different. So we can see that in this program called sunfax.java. So here we have two variables of type double, distance and mass. Again, we're declaring them both in one line of code. Then we have the initializations for these variables. They're both using the E notation. Okay, see they both have E in there. So this would be 1.49, etc., times 10 to the 11th power. And this one is 1.9, etc., times 10 to the 30th power. And when we display them, they're going to display in exactly the same way as we typed them, because we didn't tell it to do anything different. So there you have it. The sun is 1.49, etc., times 10 to the 11th meters away. The sun's mass is 1.9, etc., times 10 to the 30th kilograms. Okay, those are very large numbers. The next data type we have is arguably the simplest of all the data types. It's the Boolean data type. This was named after a mathematician. His last name was Boole, George Boole. And the Boolean data type can only have two possible values, either true or false. It can only have one or the other. It can't have both at the same time, and it must have always one or the other. Keep in mind that the value of a Boolean variable can only be copied into another Boolean variable. So you cannot store a Boolean in any other data type. Let's look at an example that uses the Boolean data type called trueFalse.java. So here we've created a variable of type Boolean and named it bool. Then we've assigned it to true. So this is its initialization. Okay, you want to take some time to differentiate the terms and learn your vocabulary. Okay, this is a declaration. In other words, we're creating the variable, but we're not assigning it a value. We're allocating space in the memory for the variable. So this is the declaration. This is the initialization. Okay, and then here we display the value of the variable. So what do you expect to see there? True. Correct. And then we simply change the value to the other possible value, that being false, and we display that. So go ahead and run it, and you should see true followed by false on separate lines because we've used the print line statement. Okay, questions? Now you can declare and initialize in the same line of code. That's another option that you have available to you. It's acceptable in Java syntax. So for example, we could put equals true all in one line, and then I'll do what's called comment out this line. In other words, I've turned this line of code into a comment, so it is no longer an active part of the program. That's actually a common technique that's used when you're in the early stages of debugging a program. You comment out a line of code to make it inactive in case you might need it again later. So I've commented out that line of code, but it is declared now in the first line of code, and it still works the same. Okay, so I'm just showing you different options that you have in terms of Java syntax. You can declare one variable or many variables in the same line as long as they're of the same type. You can declare and initialize in the same line as shown here, or you can declare first and initialize later. But you do need to declare and initialize before you can use the variable for anything else. So that's a requirement of Java. The last data type we have is the character data type. The keyword for that is simply CHAR, and it's typically pronounced char, even though it's short for character. Character literals are enclosed in single quotation marks. We've seen examples of this before, but here are some examples. We have single quote, lowercase a, and then another single quote. So that's a single character. Obviously, that's the lowercase a in your keyboard. Here's another one, capital Z. This one's a little bit different. It actually consists of two symbols, okay, \n. But we learned about that as a special case, that being an escape sequence, right? So in Java, that's the escape sequence for what? New line character, right? So that's a single character, even though it's comprised of two symbols. And then this example is a digit, the number 1, also a single character. Now keep in mind, though, that if we're storing a digit in a character, it still behaves like a character. In other words, we can't do math with it. We cannot add two characters together. Even if they happen to be storing digits, they're still characters, okay? You want to keep in mind the difference between char literals, character literals, and string literals. So remember that char literals are enclosed in single quotes, as shown here. String literals, which can consist of one or more characters, are enclosed in double quotes. Let's look at this example, letters.java. So in this example, we've declared a variable of type char. Then we've initialized it to the letter A. And what do you expect this will display to the screen? The letter A, capital A, correct. And then we change the value to capital B and display that to the screen. So go ahead and run that. And there you have it, A and B on separate lines because we use the print line statement. Okay, questions on that? Unicode. Now the Unicode system is basically universal at this point. Most computers will recognize the Unicode system. It's a way of representing all of the characters that are available on the computer as numbers, and it's a standardized code. There are currently 65,000 different characters that can be represented by the Unicode system. That's a lot. That's way more than the number of characters on your keyboard, for example. Your keyboard has maybe 100, okay? The Unicode system has 65,000. So each character takes 2 bytes. So type char requires 2 bytes. The first 256 characters are compatible with the ASCII character set. That's ASCII, which stands for American Standard Code for Information Interchange. That's pronounced ASCII, that acronym. And let's look at an example online of the ASCII table real quick. So there's lots of these available online. Here's one, ASCIItable.com. So this first part of the table here lists decimal values. Then it lists the equivalent hexadecimal and octal values. We're not going to worry about those right now. Then it lists the character. So the first, basically 31 characters, are not available on your keyboard, but they are characters nonetheless that are essential to making the computer work. The characters on your keyboard start right around 32. So character 32 corresponds to the space character. Then you have some special characters here. Then you have the digits 0 through 9. Then more special characters. And then capital A starts at 65. And while I don't expect you to memorize the whole table, I do want you to memorize that one. Okay, capital A corresponds to decimal 65. You want to memorize that. Okay. Then you have other capital letters immediately after it. So if you remember that capital A is 65, you can figure out the decimal values for all the other capital letters pretty easily, right? Then you have some more special characters, and then you have the lowercase letters after that. And that's important because if we were to sort words and we wanted to sort them in alphabetical order, unless we remembered that the lowercase letters all come after the capital letters, we could end up with something where a word that starts with, say, a capital Z would actually come before a word that starts with a lowercase a. And we wouldn't want that, right, if we were sorting in alphabetical order. So that's why you need to understand how this works, that the way they're organized, all of the capital letters come before all of the lowercase letters. And then we have the extended ASCII code, which goes into the Unicode territory. So these are special characters that you can display to the screen that are not available on your standard English keyboard. Although if you have a Spanish keyboard, I would imagine that this character, number 168, which is an upside down question mark, would probably be available because that's the standard part of the Spanish language, just as an example. So different languages have different character requirements, so their keyboards might be different, and the character numbers that they're accessing might be different. And this keeps going. They're not all listed on this particular table, but there's a lot of characters available. So let's look at an example, letters2.java. So here we have the same variable letter, also declared as type char. But look at this. Instead of assigning it to a character, we've assigned it to a number. What do you think that that's going to do? Can't hear you. It's going to be the capital A, right? So we've assigned this variable of type character to 65, but we just saw that 65 represents capital A. So that's what will happen when we display it. It will not display 65. It will display the character equivalent, which is capital A. And what do you think 66 is? Capital B, correct. Okay, any questions on that? It's just an example, just to show you the mechanics of how this works. Yes?
As far as the name for those, why don't you make them both letters? You want to change one or the other so you
Well, we're just dealing with one variable at a time in this example. So it's only one variable, and we're just showing that we can assign it or initialize it in this case, and we can change its value to something else later. That's all this example is showing. It's not. You could do that. That's just not the purpose of this particular example. But yeah, you could have letter 1 and then letter 2. And we'll assign letter 1 to 65 and display letter 1, and assign letter 2 to 66 and display letter 2. And that would work as well. But what would happen if I tried to display letter? Letter 2 is not used. More importantly, it'll give an error because this variable letter doesn't exist. I didn't excuse me, I didn't declare it. So you have to keep in mind that your variable has to be declared and initialized before you can use it. Okay. Let me put it back the way it was. There we go. Any other questions? So this is a reminder that at its base level, the computer only understands binary. So the computer is not actually storing 65, it's actually storing excuse me, a sequence of zeros and ones, such as shown here. So all that just to get at the letter capital A. And then here's the symbol, the series of zeros and ones for capital B. So when computers were first invented, the first computers that were written had to be written like this, a bunch of zeros and ones. So just be thankful that you don't have to do that. We can write in a higher level manner. Now, as we talked about earlier in the class, and something that's really important to understand is that the equal sign in computer science has a slightly different meaning than an equal sign in algebra. In algebra, the equal sign is used in an equation, but in computer science and in Java, it's an assignment operator. And there are some rules that dictate how that works. The operand on the left side of the assignment operator must be a variable name. So you can only have a single variable name on the left side of the equal sign, ever. That's all you can have is one variable name, nothing less and nothing more. Oops. And then the operand on the right side must be either a literal expression that evaluates to the type or is simply that type of variable. So what that means is when you have your operand, your variable name on your left-hand side, it's always of a particular type. It's either a byte or a string or an int or something. So when you put your code that's on the right side of the equal sign, whatever you put there has to evaluate to that type of data. So if your variable on the left side of the equal sign is an int, then it's up to you, the programmer, to make sure that whatever you put on the right side of the equal sign will evaluate as an int. Okay? If you have a string data type on the left side of the equal sign, then it's up to you to make sure that whatever you put on the right side of the equal sign will come back as a string. Okay? So you have to make sure that the type matches, or else this assignment operator will be invalid. You'll get an error, either a compile error or a runtime error, depending on exactly how the code is written. So let's look at an example here that uses the int data type. So in one line of code, we are declaring two variables of type int called month and days. We're assigning them values down here. So month gets initialized to 2, days gets initialized to 28, and that's actually appropriate because we are currently in the month of February. And then this simply displays month and then the value of month. Remember that this plus sign in this context is what? Concatenation, right? It's concatenation here, not addition, because it's next to a string. So it concatenates the word month with a number, then the word has, then another number, then the word days. Okay, so there's lots of double quotes there. So you need to keep track of which is a starting double quote and which is an ending double quote. So in other words, this is a starting double quote, this is an ending double quote. Anything in here is a literal string. And then after that second double quote, we've got a plus sign, a variable name, and another plus sign that is not a literal string. So this will give us the value of the variable month, not the word month, and not a plus sign displayed to the screen. Okay, so you have to keep track of that, and it switches back and forth a couple of times in this example. So that's up to you to keep track of that. Remember that once they're declared, they can receive a value. This is called the initialization. So again, this line is the declaration. We're declaring variables of a particular type. That type cannot be changed once it's created, and it's allocating space in the memory, and that space will remain reserved for these variables for as long as the program is running. Then down here, we are initializing the variables. We're giving them their initial values. Okay, so you want to get that terminology straight in your head, the difference between a declaration and an initialization. You can do them in the same line, and we can look at an example of that in a moment, but still you want to know the difference between the two operations. Now, let's analyze this example a little bit. I'm going to, oh, here we go. Before we analyze, this has another variation of the syntax in which we initialize and declare the variables all in one line. So we have the keyword int, then we have the first name for the first variable, and it's assigned equal to 2. Note the comma, space, and then the next variable name, and it's assigned equal to 28. So the end result is that this first declares both variables of type int, and then initializes both variables to their first values, all in one line. So that is also available to you in Java. You can combine them all in one line, and you can do this with as many variables as you like, but they do have to be the same type. So if you want to combine variable declarations into one line of code, they have to all be the same type. You can't declare an int and a byte and a long all in one line of code. There's no way to do that with the syntax. You can declare, however, as many ints as you like within this one line of code. Now, let's analyze this. I'm going to argue that this isn't the most efficient data type choice for this problem. Why do I say that, and which data type would you choose instead? Yep. Byte, right. What's the maximum value for a byte? 127, right? So if we look back at that table, right, the maximum value for a byte is 127. How many months are in a year? 12. So you know that the value for month will never go above 12, right? How many days are in a month, or what's the most number of days you can have in a month? 31, right? So you know that the value for days will never exceed 31. Both of those will never exceed 127. So to make this code slightly more efficient, I would choose the byte data type instead of int, because the byte takes 1 byte, whereas the int data type requires 4 bytes. So you'd be using 1/4 as much memory for your data. Make sense? Remember that variables can only hold one value at a time. Local variables do not receive a default value. You have to provide that. And local variables must have a valid type. So this example of code here shows the variables being declared, okay, both of type int, but they're not being initialized. They're never given initial values. And then we try to display them, but guess what? Java doesn't know what to display because these variables don't have values. So you would get an error message. This program would not run. Okay? So you need to be aware of that. When you're creating and using your variables, they have to be both declared and initialized before you can do anything with them. Excuse me one second. Okay. Java has 5 arithmetic operators, and most of these should look familiar to you. A couple of them are probably new, so let's delve into these and see what they do. So first we have addition and subtraction. Those should be familiar to you. Not going to go over them. Next we have multiplication. So this is the asterisk, which is Shift 8 on your keyboard, and that's the standard symbol for multiplication in Java and most programming languages. All right, so that's what you use for multiplication. Next we have division, which is a /. Okay, so that's next to your right Shift key on the keyboard. Make sure you know the difference between a / and a backslash. The /, just a single /, gives you division. Well, what do 2 / give you? A comment. Okay, so this is just the type of thing that you need to keep track of. All right. Also, it's integer division in Java, and we'll talk more about what that means in a minute, but it is very important to know that this is integer division, not standard division. Then this last symbol is probably new to you. This is the percent sign, so that would be Shift 5 on your keyboard, and it represents modulus. Modulus means that it takes the remainder of the integer division. Okay, so modulus gives you the remainder from the integer division. So let's look at some examples that use some of these. Wages.java. So this program declares several variables, all of type double. Some of them are initialized right away within the same line of code. Some of them are initialized later. And we can see why, for example, regular wages is initialized later because it has to have these values first. Base pay and regular hours will get multiplied together in order to calculate the regular wages. Overtime wages is set equal to overtime pay times overtime hours. And then total wages becomes the sum of regular wages and overtime wages. Okay, so a couple things to keep in mind here. Again, this is multiplication. This is addition in this context. It's not concatenation here, right? Because it's between two numbers. So therefore it's addition, not concatenation in this context. Also, the result of these evaluations are all of type double. So it matches the variable on the left side, which is of type double. Okay, so you have to keep track of that. Okay, so these will all result in a double. So these are all legal and they can be stored in variables of type double. Then we simply display the literal string wages for this week are $, and then total wages, which we had to do these three calculations before we could get to the total wages. So I'll go ahead and compile and run that. And there you have it. Wages for this week are $1,375. Okay, questions on that example? All right, so let's take a closer look at integer division. So in integer division, which is what Java uses, what would be 1 divided by 2? What would that evaluate to? Not 0.5. 0 is correct. The answer is simply 0 because it's the result of the integer division. Any decimal part will be truncated. So in other words, if you take 1 divided by 2 using old school division, and I have to do this on Paint so that it shows up in the recording. I can't do it on the whiteboard. So we have, remember this symbol, like in 4th grade division? Okay, that's the kind of division we're talking about. So we have 1 divided by 2, right? So walk me through this. Do you remember how to do this? What would be the answer here? How many times does 2 go into 1? 0. Right? 0 times. Then you have 0 times 2 is 0. Then you subtract. You're left with 1, and that is your remainder. So the answer to this would be 0, remainder 1. Okay? Does that ring a bell? So that's the kind of division we're talking about, integer division. There's no fractions, there's no decimals. It's just the divisor and the remainder, and that's it. So 1 divided by 2 would be 0. And then what about 1 modulus 2? If we had this in Java, 1% 2. Okay, remember I said modulus gives you the remainder. So what's 1 modulus 2? 1, correct. Equals 1, which we calculated over here. Okay, so that's the basic idea of the integer division and the modulus. Okay, it's really important to understand that to be able to do math effectively in a Java program. We also need to keep in mind the precedence, the order of operations. So you probably remember an acronym to remember the order of operations. PEMDAS, remember that? Please excuse my dear Aunt Sally. Maybe you know a different variation of it, but that's supposed to help you to remember the order of operations. Parentheses, exponents, multiplication, division, excuse me, addition and subtraction. The order of operations in computer science is basically the same. Parentheses do come first. We haven't gotten to exponents yet. We'll probably get to that later in the course. But we also need to have this symbol, the unary negation. If we have a minus sign before a number, okay, that means we're taking the negative of that number. So that's the highest priority. Then we have these three at the same level of priority. So that's multiplication, division, and modulus. And that makes sense with PEMDAS, right? Multiplication, division, okay? So multiplication, division, and we're adding this modulus, which is basically just an offshoot of the division, okay? We also have to remember that within those operators, they are executed left to right. So in this particular example here, okay, -4 plus 4 modulus 3 times 13 plus 2, okay, this part 4 modulus 3 is executed first before we multiply times 13, okay? And then the last priority is addition and subtraction. So what I'd like you to do is to take out a piece of paper and pencil if you have it and work out these examples to make sure you get the results as posted here. And we'll go over it in just a minute. All right, so why don't you go ahead and work those out. All right, well, let's go over the first one. First one's pretty straightforward. We have x equals -4 plus 3. So that basically means we're adding a -4 to a 3, which is -1. Straightforward, right? Any questions on that? All right, next one's a little bit more complex. We have x equals -4 plus 4 modulus 3 times 13 plus 2. Now, we have to follow the order of operations. So the first thing we have to do is remember that this is a -4. Okay, so we keep that, we carry it down. The next thing we have to do is the multiplication, division, or modulus, but they are executed left to right. So we first do 4 modulus 3. What's 4 modulus 3? 1, that's correct. In other words, we're saying that if we take 4 and divide it by 3, the remainder of that division would be 1. So 4 modulus 3 is 1. then we have to multiply that 1, the result of this, times 13. So 1 times 13 is what? 13. Okay, so then that leaves us with -4 plus 13 plus 2. All right, let me jot that down over here. So that's -4 plus 13 plus 2. And we can simply add those together. And what do we get? 11. Okay, so that's that one. Now let's look at the last one. We have 6 plus 4, sorry, 6 plus 3 minus 4 plus 6 times 3. Of those operations, which one do we have to do first? Multiplication, right. So that becomes 18. All right, so let me write that down. So it's 6 plus 3 minus 4 plus 18. Then we can simply add those together. All right, 6 plus 3 is 9, minus 4 is 5, plus 18 is 23. Okay. How are we doing on time? 2 minutes left. Any questions on those? Good? All right. So here's another example. Okay. This one uses parentheses. So we have to execute the parentheses first. So in this example, we would multiply this first. So 4 times 5. Then we would do this subtraction, again, because it's in the parentheses. So that would give us 20 divided by 3. What's 20 divided by 3? In terms of integer division? 6. That's correct. So then we would do 6 minus 25, and that would give us -19 for the answer. Okay? So that's how that works. You can also combine the assignment operators, which is, shouldn't really be surprising that you can do that. You can do it in algebra. So, but these combined assignment operators are a little different. Let's look at some of these. So if we put a plus and an equal sign right exactly next to each other, no spaces in between, that's actually shorthand for the variable equals itself plus some number. So in other words, these two assignments would be equivalent. We could write x equals x plus 5. That would be the normal sort of longhand way to write it. The shorthand way to write it would be simply x plus equals 5. So the way that would work is, let's say before we got to this line of code, let's say x had a value of 3. Okay, so we come down here and we have this line. It says x equals x plus 5. X is currently 3, so we evaluate 3 plus 5, and that becomes the new value of x. So x would become 8 in that case. All right. So we'll finish this up next class. Thanks very much. Have a great day.